Everyone can see my screen, right? Can see my screen?
Yes, we can see.
Yes, sir.
Hypothesis testing. Hypothesis testing, let's take any experiment you take. Initially, we sorry, 1 second. Initially, we don't know whether it works or not, but we experiment it, and finally, we'll find out whether it works out or not. In some case, it can be true or false, or it can be right or wrong kind of. Basically, we started any experiment with hypothesis. Hypothesis is nothing but an idea plus with a few facts in hand. Okay, so it's a idea or explanation of something that is based on a few known facts. Nothing else. That is the whole idea of hypothesis. So this is something that I believe may work based on these facts. It can be the facts can be bare minimal. It not be have huge amount of facts that proves that it's right at the first place itself. This is the first step. And in hypothesis testing, there are two kinds of things: null hypothesis and alternate hypothesis. Whenever you come up with idea with few facts and you start experimenting things, you're going to start with null hypothesis. Null hypothesis means whatever I believe this hypothesis is wrong. So we initially start with idea that whatever I believe is by itself is wrong, I need to prove that it is wrong. You get it? So I believe something, idea plus few facts. We call it as hypothesis. Right? I take this hypothesis, I believe that the hypothesis itself is wrong. So if I prove this wrong hypothesis as wrong, then what happens? It will become right, right? So when it is actually, when we prove this hypothesis that null hypothesis is wrong, then we immediately say that alternate hypothesis is right. That is, the stated facts are correct and whatever I believe is in fact right. Any questions?
Is it vice versa also?
Vice versa also, you can take it. It's your choice. But the approach is like, the typical experiment is going to be in this way. In fact, no one is going to say that this is how you have to experiment. If at all, we have to constructively define this, how it is going to be. Measures of dispersion. So there are like, we have seen interquartile range, isn't it? Outliers. What is IQR? Sorry. What is IQR? Percentile also been explained. Variance also we have seen. Standard deviation, variance, we have seen that. What is something that we haven't seen here before?
Percentile.
Percentile, we haven't seen percentile, 20th percentile, 50th percentile, 40th.
Yeah, that is in the box plot we have seen that.
All right. So what about range? Have you seen range?
No.
We have not seen.
So range is damn simple. It's not difficult. Let's take, we have data like this. The range is going to be the max value minus minimum value. So what is max value? 28 minus 22. Minimum value is 22. It's going to be 6. So we have minimum value 22, max value 28. In between, the variation is only 6. It can be minimum value plus 1 or minimum value plus 2 or minimum value plus 3 or minimum value plus 4, minimum plus 5, no, minimum value plus 6. Not more than, or else maximum value minus 1, maximum value minus 2, maximum value minus 3, maximum value minus 4, maximum value minus 5, maximum value minus 6. That's all. So range will help us in tell us, like, it's going to tell us the variance in which a variance between the minimum and maximum value. That's the whole idea. These concepts are well discussed, and I'm going to take another example, real world example for percentile, but not in, okay, if you take this data, wherein we have a row number, the employee ID, this constitutes an employee ID, and the salary they get. Let's take per month. Okay, so let's take, we need to find, you hear this percentiles in IIT exams kind of. So what happens in IIT exams? 1 second, I'll come back. All right. So here we need to find out the percent. Let's take 80th percentile observation. You hear these percentiles in IIT exams, right? So they will get but the problem with percentage is it is difficult to judge who are all is going to be eligible for the exam. Let's take 99% percentage is the eligible criteria. That will be, more than what they require. Then they come up with this percentage. The percentage, the way it works is, let's say that in this data set, we want to find 80th percentile, right? Everything being sorted out, you can see. And let's say total observations multiplied by 80th percentage. So we need to calculate 80. If it is 85th percentile, we need to mention like 85. If it's 90th percentile, it's going to 90. Okay. So 80 percentile. Total number of observations are 15. 15 multiplied by 0.8, which is 12. So it indicates that it is 12th index. So this guy has, better than 80% of these are all the 80% people. And this guy sits on top of this 80% people. That is what this indicates. So they came up with this percentage, and that is how they they picked the right students. Even in IIT, they say 99.9% percentile. That is how the people should have, right? If it is 99.99%, it's going to be 99999, right? Any questions on percentile?
So can you explain the definition? I got this, but the definition observation in a group of
So
observation.
this 80%, right? 80th percent, this 80th percentile. So this means he is better than 80% of the people. So these are all the 80% people category. So this guy is on top of this 80% people. That is what this indicates.
Who is above them?
Yeah.
Okay. Got it, sir.
Next one is sampling techniques. We already seen this simple random sampling and stratified random sampling, right? Can someone explain me what is simple random sampling and stratified random sampling, the difference between these two? We have seen it.
Simple random sampling is like that. From the any population, we take any portion of the data from it without any conditions or anything.
Randomly picking up some number.
Randomly picking up.
Okay, what about stratified sampling?
With some condition, let's say from the population, if I want to take male portion whose age is greater than 30. So
yeah, basically we are stat is nothing but groups. We are dividing it into groups rather than as one chunk, right? When it comes to undersampling, oversampling, we discuss that later in machine learning internals. Okay, so right now I'm not going to get into it, but the only thing is here, when we say mu, it is standard, it's a population mean. When we have X bar like this, it is sample mean. Okay, so when they say X bar, we can say that the data that the mean that they have calculated is on sample data, not on population data. When you have mu, we clearly say, says that the mean has been calculated on population data. Okay, standard deviation. This is population standard deviation, and this one is sample standard deviation. This one is population variance. This one is sample variance. That is the only thing you need to remember in this script. Apart from it, everything else has been discussed except undersampling, oversampling. We'll discuss that later.
So what is the stratified sampling, sir? Strata?
I'm not going to explain it because it was explained in statistics, and
Oh.
here we got it and we explained it. And you're again
Okay, I'll look into that video. Sorry, I forgot.
You have to practice. Statistics library, so we need this library, and even though we can get bunch of statistical information from pandas, there are few things like skewness kind of we can get only through statistics and other libraries. So we have a statistics library wherein we can get mean. If we provide data to it, we can get median. We can even get mode. I think in in pandas also we get mode, and specifically we can go column by column basis, and S dot variance, we can get standard variance of it, standard deviation. So this is an alternative to the regular libraries that we have. Okay, this is an important one. And there is something called statistical significance. The whole idea of statistical significance is, let's take that you have, you brought an idea, you implemented it, and you got so and so change. But this change that you brought in may or may not be significant enough statistically in the sense, and what the idea that changes that you have made may or may not really have the impact to bring that change. Let's take customer care center, wherein we will have IVR, right? When we call to customer care, a machine will speak to you. If you want to speak to customer care representative, press 8 or press 9. If you need balance, press 1, kind of, right? So they say that they made changes to that IVR itself to bring down the amount of time that the customer is waiting. The overall right now, the turnout is, around 100 seconds plus or minus 20. That means 80 to 120 seconds current waiting period. Who call the customer care? What is that waiting period? Before they connect to customer representative or before they get the information they need. One second. Before they get the right information they need, right? So it is now 100 plus or minus 20. So this data has been calculated on all the previous data they have. What does that mean? It is population. So this is 100 plus or minus 20 is actually population mean waiting period, right? And then they brought few changes to the IVR to bring down the waiting period. They might have added few more things. Okay, something that they require, it's automated and they kept it in IVR. Now, after the change, they again, tested it. They have taken 100 sample calls and they found the waiting period now is 95 seconds. Of course, it got reduced from 100 to 95 seconds. Thing is that they check only on 100 samples, right? Just consider that they have a few branches in Chennai, Mumbai, and one in another one is Kolkata, another one Delhi. So the changes they made is only in one particular division. Let's take Chennai itself. They have not made changes to any other place. So, but whatever the idea they brought in order to implement widely, I mean, across all the branches, all the divisions, all the zones, then it has to, we need to be sure that it works, right? So how do we know that it works or not? Unless we test it. They tested it in the same zone itself, Chennai itself, and they have taken 100 sample calls and they understood that it in 95 seconds. Now they need to find out whether this change this improvement that they got 100 to 95 seconds. In fact, it is 100 plus or minus 20. It can be 80, 81, 82, up to 120. So this is significant enough or not, something that we can implement it widely or not. That is the whole question. So how do we know that? We need to find out statistical significance. So how do we do that? So now we need to have alpha first. What is alpha? It's 0.05. So it can be even less or more. What does that mean? 0.05 means 5% error, 5%, 95% accurate. Whatever the predictions that we make, whatever the statistics that we do, it has an acceptance level of 5% error, which means 95% accurate. If
Yeah,
the
sir, what if it was 90%? Will we take the significance level 10% also?
Yeah, significance levels, if they're expecting 90% accuracy and 10%, then it's going to be what? It's going to be 10%, right?
Point one. Yeah,
0.1.
point, yeah, yeah,
So then it's going 90% accuracy. So
90%.
usually in across the industry, the 5% is acceptable, but in some case it can be even 99%. This is 99%, isn't it?
Yeah.
So we can even go deeper. But okay, let's go with 0.05. We can change this one. So alpha significance level is 0.05, which means 5% error, which means 95% accuracy. And this is again depends on client's acceptance. Without acceptance, obviously we can't go further. And the next one is we need to sort out all the values we have. So this is population mean. So how do we represent it with mu 100? What is the sigma? 20 seconds, plus or minus 20, right? Deviation is plus or minus 20. So sigma is 20. And what is the sample they have taken after bringing the idea, implementing the idea? Sample is 100 calls. N is 100. And they observe that waiting period 95 seconds. This 95 seconds is X bar. Why do you think this is X bar? Why not mu?
This is the sample.
Exactly. This is sample mean. So the sample in the sense here we have taken, we have judged that it is 95 seconds waiting period only on 100 calls. We're testing it. We're testing the idea. 95. So any questions up to here? Usually the hypothesis is going to start with there is no change in the waiting period. That is how it's going to be. So we are proving it as wrong. And if we can able to prove wrong as wrong, then it's going to be right. But the actual thing is we are trying to prove the waiting period has reduced. Okay, we'll see whether it is really reduced or not. A significant level in a way that we can implement widely. Okay, is this clear? This part is clear.
Yes.
Yes,
The next one is standard deviation. Actually, the standard deviation or sample standard deviation, standard error, we call it as this sigma, the population sigma by square root of n. Square root of n in the sense here is square root of 100. So it's going to be 20 by 10 is 2. Standard error is very important when we calculate this Z score. Okay, because you're going to use this one. Sample standard deviation or standard error, we call it as. So X bar, which is this one, minus, what is Z score formula? X bar minus mu by sigma, right? So X bar, that is sample mean by minus mu, that is population mean by this standard error. So 20 by 10 is 2, right? So what we got, 95 minus 10 by 2, that is minus 5 by 2, minus 2.5. Any questions up to here? Is this clear? I hope you got the calculation. Just it's simply Z score, nothing else. And I have given an image here, Z score negative table. Okay, I think it's already been uploaded. You can download it from there. I can open it. It is minus 2.5. You need to cross check it in this one. So how do we do that? We need to check this minus 2.5. If it is, let's take minus 2.55. Okay, then we need to do like minus 2.5, and then this is 0.05, right? This one, this cross section, this part, 0.005039. But here in this case, minus 2.5. So minus 2.5 means minus 2.50. So we need to go with 0. What is minus 2.50? 0.00621. 0.00621. So we 0.00621 as per just code table. So it means that this is proportion. 0.0062 is proportion. What is the percentage? It's quite easy to understand in percentages, right? Multiplied by 100. How do we how much we got? 0.62%. That means less than 1% error. P is less than 1% error. But the actual acceptance level is 5%. But what we got here is 0.62%. So this value should be less than or equal to this one. Is it less than or equal to this one or not?
Yeah, less than.
less.
So it
Yes, sir.
means the idea they brought, the changes they made are significantly good enough so that you can implement it across all the zones. So we are rejecting the null hypothesis, we're accepting the alternate hypothesis. That is what this means. Got it? Sirisha, at least you can say or You're
Yeah,
not responding at all.
I understood. I understood.
Why don't you speak out if you okay? You have to speak out unless you be more interactive. It's difficult to
I
understand.
have a question. We have started that wrong.
No, the question is why didn't you understand? Why didn't you raise that question earlier?
No,
I think only when I ask you to ask
no,
question.
it's not like that. I am about to ask, but I am
Okay,
trying
go ahead,
to.
go ahead, go ahead.
Yeah. So we have started that wrong, that whatever null hypothesis that we have to prove it wrong. Then,
Right.
but what we have started is it should be less than significance level or something is less than 5%. But P is, I mean, it is less than 5 only, right? So I didn't understand what we have proved. What is wrong that we have proved?
If P is less than alpha,
Oh,
then we need to reject. So we are proving that null hypothesis is wrong.
okay.
What is null hypothesis? Is the no change in the waiting period. In
P-
fact, it is basically like P is greater than alpha. If P is greater than alpha, accept null hypothesis. But P is not greater than alpha, right?
Okay, understood.
The next one is I have given a data set wherein a bunch of columns. Actually, I already discussed in this one in detail. You remember qualitative, quantitative. What is the difference between qualitative, quantitative, and what are subcategories it has? Can someone explain me what is discrete, continuous, nominal, ordinal, quantitative, quantitative?
Sir, qualitative is the categorical types of data.
What is that?
Qualitative,
Qualitative is what?
categorical types of data.
Quality in nature. Okay. Okay.
Yeah, categorical. And
Yeah.
quantitative means numerical data. It should be discrete or it should be continuous. Like
But
in
here we
qualitative,
have created history 1 1 1 1. Is this quantitative?
categorical. It
Categorical.
should be
This is
categorical.
okay.
And in that quantitative, there should be discrete and continuous. Discrete means if there should be no decimal places. Like
Yeah, there is no possibility of having decimals. If there's no possibility of having decimals, the actual data set that you got may not have decimals. But if there is no, there is a possibility of having decimals. But you need to cross check whether there is a possibility or not by knowing the nature of the column. Right? If we got the point. So discrete means it can be, when we get data, we need to we need to question the very nature of the column, that whether is there any possibility of having decimal values or not. In the original data set that we got may not have decimal values, but we need to cross check whether there is any possibility or not.
And nominal and ordinal difference is that
What about continuous? What about continuous?
Continuous is there should be means like a temperature, means any decimal value also be from or a height of a person.
There is a possibility of having decimal values, right? In this case, if you look at the income, it doesn't have decimal values. We added 0 0, something that we can ignore it. Doesn't have any decimal, but there is a possibility of having 50 cents or 30 cents, right? So that is what it means. All right. Next one.
Order nominal means the ordering doesn't matter. Whether
It's
it
not
should be
ordering
like
doesn't matter. The order is not possible in that.
order is not possible.
Qualitative
But
nature, but order is not possible. Yeah, ordinal.
In ordinal, let's say degree, we should be 10, 12, then graduates or masters. So in that case, the order is means,
So
we can do the ordering.
It's
We
again
can,
qualitative nature, but something that we can order it, like 5-star movie reviews, 5-star, 4-star. And in this case, it is create history, dependence. So these are all comes under ordinal. Okay, this is an example that I have given for the same thing. So if you don't understand, like, go back and go through those concepts. It's the same thing. Listed out here, that's all. All the numerical, when I say numerical columns, it is only, I'm referring to continuous data. When I say categorical, I'm going to refer nominal, ordinal, and discrete. Okay. We have completed statistics and advanced statistics. Any questions on this? Tomorrow we'll see mathematics. We'll finish it off tomorrow. This one. We don't have anything pending. Tomorrow we are going to finish off mathematics and statistics. Immediately after that, we'll start gradient descent and machine learning template. What is today? Okay, so I think on Friday, if you can able to complete machine learning template, you have 2 days time to complete the project, Saturday and Sunday. So I'll provide, I'll explain the script. I'll provide data sets. I'll explain you where all the changes, what all the changes that you have to make for every data set. And then you need to complete by Sunday. So when you're about to attend the Monday session, make sure that you submit all the projects. Okay. And from 29th onwards, we'll start dive deeper into the machine learning template. I mean to say machine learning concepts. So by end of the next week, you will complete all the machine learning internals in a way that you will be good at machine learning part. And then the deep learning starts. Right. So any questions in today's session?
Sir, actually, I forget that Z square.
Yeah, score
I do
table.
that one. No, this I understand, but what does that interpret? That
So
Z
this
square?
table we have for the
all
Z score, we have to follow this one, right?
Yeah, algorithmic table this is.
Uh,
Algorithmic table. So I have taken a picture of it and we need to look at this values minus 2.5 and zeros. We need to get that particular value. So we get in terms of the p value. So we are not going to use Z score is not going to give the actual value. It's not going to give the p value. In order to convert the Z score value to p value, this is the table that you have to follow. Got it?
okay.
And there is another place where we use the score table, the same picture. So basically, I have taken a copy from algorithm. You might have heard this book, right? In 10th standard, we would have seen this algorithmic book,
Yeah, logarithm books,
logarithm book, blue book.
blue book. But sir, that question is that Z square, what exactly it is inferred to us? That means
So
for
it
the
will help
data.
us in converting Z score value to p value so that we can compare to the desired or the expected p value. It will help us to convert Z score value to p value.
Okay.
Without going through the underhood operations. That's the whole thing. If you look at Z score value to p value conversion formula, you can get a lot of things here. So you need to calculate all this stuff. Rather than that, you can directly refer the algorithmic table.
So p value is that 0.65%.
Yeah.
Is that what the p value is?
The final output is 0.065. 0.0062, in fact. It's 0.62%.
So after getting 2.5, why you referred it to 0? I mean, from the 0 itself column.
Because it's 2.50. We don't have
Okay, the
we have
decimal value.
0.1, you need to look at 0.5,
Okay.
right? So I told you this. I think
Yeah.
you keep asking the same questions. All right. Okay, we'll continue tomorrow. See, any questions in today's session?
No, sir.
And so you need to practice a lot. You can't manage things like the way you did for basic libraries and all. You need to practice a lot. From here onwards, the actual machine learning already started. All right. Thanks for
Yes.
joining.
Yeah. Thank you, sir.
Thank you.
Thank you, sir.